If you turn the pages of the history of Odisha, you will find there is a complete devastating cyclone called super cyclone in the year 1999. After this super cyclone, a gas was leaked from the Oswald Fertilizer Limited Paradip, which creates havoc and panic among the locals. Do you know the name of the gas? Can you answer this? Okay, let me answer this. The name of the gas is ammonia. Ammonia is a poisonous gas. Because of the ammonia gas, people got panic in Paradip. Once again, ammonia is a nitrogen containing compound. So students, I mean to say, today we are going to discuss about nitrogen family, the 15th group elements. And these 15 group elements are also called nicogens. What do you mean by nicogens? And why these elements are called nicogens? Nicogen is derived from the ancient Greek word nigen, meaning to choke. Because of the choking property of nitrogen gas, these compounds were termed as nicogens. Okay? So, let's start the nitrogen family and the compounds of nitrogen. These 15th group elements on nitrogen family includes nitrogen, phosphorus, arsenic, antimony and bismuth. These are the 5 elements belongs to 15th group, that is nitrogen family. First, we will discuss their physical properties, then chemical properties, then compounds of nitrogen, then allotropes of phosphorus. First, the physical properties of nitrogen family or 15th group elements. Just have a look, the physical properties of 15th group elements. First, the atomic number, just use the magic number 2, 8, 8, 18, 18, 30 to get the atomic number of these elements. Nitrogen belongs to second period of the periodic table. So, adds 8 to get the next member, that is phosphorus, whose atomic number is 15. Then add 18 to get the next member, arsenic, whose atomic number is 33. Then add 18 to get the next member, antimony, whose atomic number is 51. And finally add 32 to get the final member of this family, that is bismuth, atomic number 83. Okay? So, these are the atomic numbers of the members of 15th group. Coming to the electronic configurations, these elements have 5 electrons in the outermost shell with the general electronic configuration NH2NP3. That means there are 2 electrons in s orbital and 3 electrons in p sub shell. As you know, p sub shell has 3 orbital px, py, pz, which are degenerate. I mean, all the 3 p orbitals are identical in energy. Hence, all the 3 p orbitals obey the Hund's rule, having the electronic configuration NS2, NPX1, NPY1, NPZ1. Let me show that on the whiteboard. Just have a look. NH2, NP3, 2 electron in s orbital, 3 electron in p sub shell. S orbital, this one, p sub shell, it has 3 orbital px, py, pz. As per the Hund's rule, all the 3 p orbitals are half filled. As per the Hund's rule. As you know Hund's rule, what is Hund's rule? That electron pairing cannot be taken place in a set of degenerate atomic orbital. These are the 3 degenerate atomic orbital. I mean orbitals with same energy. So, electron pairing cannot be taken place in a set of degenerate atomic orbital unless each atomic orbital is singly filled. So, these are the 3 p orbitals which are singly filled. So, NP3. electronic configuration NH2NP3. And you see the p sub cell is half filled because p sub cell can accommodate maximum 6 electrons, as each orbital can accommodate 2 electrons as per the Pauli's exclusion principle. So p sub cell having 3 orbital can accommodate 6 electrons. But here p sub cell has 3 orbital, all the 3 p orbitals are half filled. Okay, so p sub cell is in half filled state. So this is that electronic configuration of these elements is NH2 and half filled p sub cell, which imparts stability to these elements, which also affect the general physical properties of these elements. Because of this electronic configuration, the general physical properties of the elements are also get affected. Let's see some of the physical properties first. First physical properties you can have from the TV screen that is displayed on a TV screen, that is ionization enthalpy. Just to see, can you compare the ionization enthalpy between that 14th group elements and 15th group elements, also 16th group elements? We know that along the period in the predictable, the ionization enthalpy increases. But see, 15th group elements possess higher ionization enthalpy than the 16th group elements. Why this is so? Because of the extra stability gained through half-filled p sub cell. Extra stability gained through half-filled p sub cell. That is why they are quite stable and they have higher ionization enthalpy. I mean more energy required to remove the electron from the outermost cell. So they have higher ionization enthalpy than the succeeding elements. It is oxygen. Nitrogen has higher ionization enthalpy than oxygen because of this stable electronic configuration. So 15th group elements possess higher ionization enthalpy than the previous elements, also possess higher ionization enthalpy than successive elements. Okay, preceding elements, successive elements. Nitrogen family, higher ionization enthalpy than previous elements, I mean preceding elements, and also possess higher ionization enthalpy than successive elements. Okay, so this is ionization enthalpy, but you see, mark the ionization enthalpy here, which is displayed on a TV screen. It is given first ionization enthalpy, say, which is in kilojoule per mole, 1402, then 1012, see the decrease, 400 kilojoule approximately, decrease in ionization enthalpy, that is 400. Obviously, ionization enthalpy decreases down the graph. Ionization enthalpy of these elements decreases down the graph. Why? Because size increases, the atomic radius increases, so ionization enthalpy decreases. But mark the difference after phosphorus, see the difference between the ionization energy. After phosphorus, difference between the ionization energy is small. Compared to the first two elements, nitrogen, phosphorus, difference is maximum. After phosphorus, this difference is small. Why this is so? Because you see the electronic configurations. After phosphorus, the D sub cell is in the process of filling. D sub cell is in the process of filling. And D electron can't skin the nucleus effectively like S and P electrons. The skinning by D electron is minimum because D orbital is diffusion space. So they are not closer to the nucleus. They can't skin the nucleus effectively like S and P electrons. As a result of which, effective nuclear charge decreases. So ionization energy, what we are expecting the ionization energy should be more, but it is not so. That ionization energy decreases. We are expecting a more decrease in ionization energy, but because of high effective nuclear charge, that ionization energy increases here. Do you follow me? So that down the groove, the ionization energy decreases, but after phosphorus, the difference of ionization energy is minimum because of poor skinning by D and F electrons. Arsenic 10 D electrons, antimony 20 D electrons, bismuth 30 D electrons and 14 F electrons. So D and F electron in bismuth, the D and F electron, 30 D and 14 F electron, D and F electron can't skin the nucleus effectively. So effective nuclear charge increases. That is why the difference of ionization energy is small. Coming to electronegativity. Electronegativity, see, same thing, electronegativity also decreases down the groove. Once again, because atomic radius increases, so electronegativity decreases. But see, after phosphorus, once again, difference is too small. See the nitrogen electronegativity, 3. and phosphorus 2.1. Then after arsenic 2, antimony bismuth 1.9. Difference once again small. Why? What the reason? Student, what is the answer here? If the question asks you that after phosphorus difference of ionization energy, also the difference of electronegativity is small compared to the first two elements, I mean nitrogen and phosphorus. What is the answer? Answer is poor skinning by D and F electron. Because of poor skinning, the effective nuclear charge increases, ionization energy increases, electronegativity too also. We are expecting a much decrease in electronegativity as well as ionization energy, not so, because of poor skinning by D and F electrons. Coming to radius, atomic radius, once again atomic radius increases, atomic radius increases down the groove. Why? Because number of cells increases, atomic radius increases. But see, once again difference between atomic radius increase in atomic radius after phosphorus is small. Same reason, due to poor skinning by D and F electrons. Boiling point increases regularly down the groove. It is given here that electronic configuration I have already explained. What the electronic configuration? 5 electrons in the outermost shell, out of which p half shell is in half filled state. The atomic radii and ionic radii both increases down the groove. Ionization enthalpy decreases down the groove. Electronegativity decreases down the groove. Okay. Next, the physical properties. Once again, let's have some idea about physical properties which is displayed on our TV screen. Coming to dinitrogen, it is given. Dinitrogen is a diatomic gas while all other are solids. First question comes, why dinitrogen is a gas whereas other members are solids? Because nitrogen is diatomic. Nitrogen is diatomic. N2, atomicity 2, and phosphorus tetraatomic, P4. So why nitrogen is diatomic whereas phosphorus, arsenic, antimony, they are tetraatomic? Why this is so? Bismuth is also diatomic. But first question comes, why nitrogen is diatomic? Because nitrogen is smaller in size. So as it is smaller in size, there is chance of sideways overlapping between the p atomic orbitals of nitrogen. I mean to say nitrogen shows multiple bonding. Nitrogen shows multiple bonding, whereas phosphorus being larger in size cannot show multiple bonding because orbitals being, as its size is large, orbitals not available for sideways overlapping, no pi bond. Whereas nitrogen shows multiple bonding or there is sideways overlapping possible in case of nitrogen N triple bond N. No sideways overlapping or no multiple bonding here. So molecular mass of nitrogen is lesser compared to the other members. As molecular mass is lesser, the force of attraction, the Van der force of attraction is weaker. So it is a gas. Phosphorus, large atomic size, molecular mass is also higher. So Van der force of attraction is higher. That makes phosphorus exist as a solid. So nitrogen is a gas, rest members are solids. Nitrogen is a gas because it is diatomic. Why it is diatomic? Because it shows multiple bonding. Why other members are solids? Because they are tetraatomic. Why they are tetraatomic? No multiple bonding. So they exist as tetraatomic molecule in order to satisfy the valency. Okay. So this is the first physical properties we are discussing, the atomicity. Now second, except nitrogen, all the elements show allotropy. Do you know what is allotropy? It is the form of the element having different physical properties but same chemical properties. So except nitrogen, rest of the elements exhibit allotropy. As you go down the group, there is a shift from non-metallic to metallic through metalloidic character. What is that? Nitrogen, phosphorus, non-metal. Arsenic, antimony, metalloid. Bismuth is a pure metal. It is again displayed on your TV screen. You can have a look from that. The boiling point I have already discussed. Boiling point increases down the groove, but the melting point up to arsenic, it increases then decreases up to bismuth. These are the physical properties of nitrogen family. We have already discussed about physical properties of 15th group elements. Now we will discuss the chemical properties of 15th group elements, that is nitrogen family. First chemical properties we are going to discuss is oxidation state displayed on your TV screen. We see the common oxidation state of these elements are -3, +3 and +5. Tendency to show -3 oxidation state decreases down the group because the metallic character increases down the group. Also tendency to show +5 oxidation state decreases down the group. Why? Why not +5 oxidation state? Bismuth has least tendency to show +5 oxidation state. Only compound of bismuth which is available in +5 oxidation state is bismuth pentafluoride. Let me write that. The compound is BiF5, bismuth pentafluoride, where bismuth exhibited +5 oxidation state, otherwise +3. Why not? Due to inert pair effect. Bismuth exhibit inert pair effect. So what is this inert pair effect? What is inert pair effect? That one of the electron pair is inert. What does it mean? It is reluctant. This electron pair is reluctant to take part in bonding. Which electron pair it is? In bismuth, let us see what the electronic configuration, and let us see which electron pair is reluctant to take part in bonding. Bismuth, it is xenon 54, then 4F14, 5D10, 6S2, 6P3. Outer shell 6S2, 6P3, 5 electrons. And see, in bismuth there are 30 d electrons, and 14 F electrons. These D and F electrons can't skin the nucleus effectively. I have already told you this. These electrons, there are 30 D and 14 F electrons, all total 14 electrons. They can't skin the nucleus effectively. So effective nuclear charge increases. As effective nuclear charge increases, the S electron pair which is more penetrated towards the nucleus tightly held to the nucleus. S electron pair is more penetrated, so tightly held to the nucleus because bismuth has high effective nuclear charge. Why high effective nuclear charge? Because of poor skinning by D and F electron. Hence, S electron pair is not available for bonding. S electron pair is not available for bonding, inert pair. Only 3 electrons are available for bonding, so it exhibit oxidation state +3, not +5. Now next point, tendency to show -3 oxidation state decreases down the group. Bismuth hardly form any compound in -3 oxidation state because it has a low ionization energy, it is metallic, okay, it is electropositive, so -3 oxidation state is not possible. Nitrogen also exhibit +1, +2, +4 oxidation state in addition to all the oxidation state. Nitrogen exhibit all the oxidation state -3 to +5. Nitrogen exhibit all the oxidation state from -3 to +5. Let me show you all the compounds having these oxidation states. First -3, it is ammonia, where nitrogen exhibit -3 oxidation state. Then comes hydrogen, where nitrogen exhibit -2 oxidation state. Then comes hydroxylamine, where nitrogen exhibit -1 oxidation state. Nitrogen 0. Then N2O, laughing gas, it is +1. Then NO, it is +2. N2O3 +3, N2O4 +4 and N2O5 +5. All the oxidation state of nitrogen are possible, but the common oxidation state of these group elements are -3, +3 and +5. Phosphorus also shows +1 and +4 oxidation state. Phosphorus also exhibit. Let me show you the compound of +1 oxidation state. S3PO2 called hypophosphorus acid hypophosphorus acid. Phosphorus exhibit +1 oxidation state. Then H4P2O6 hypophosphoric acid. Here phosphorus exhibit +4 oxidation state. Okay. So, phosphorus also exhibit +1 and +4 oxidation state. This is the oxidation state of nitrogen family. Let us see some other information regarding oxidation state. In case of nitrogen, all oxidation state from +1 to +4 tends to disproportionate in acid solution. See the word disproportionate. Disproportionate, what does it mean? It is the simultaneous oxidation and reduction of the same molecule. See the example which is displayed on your TV screen. The nitrous acid is oxidized to nitric acid. Nitrous acid +3 to +5 oxidized to nitric acid and also reduced to NO, that is +3 to +2. So, it undergoes oxidation as well as reduction, simultaneous oxidation and reduction of the HNO2. This is disproportionation reaction. Where it is possible, the oxides of nitrogen or the compounds of nitrogen where oxidation state is from +1 to +4 displayed on your TV screen. Next point is see. Similar in case of phosphorus, nearly all the intermediate oxidation state. Once again see, phosphorus also intermediate oxidation state disproportionates to +5 into +5 and -3 both in alkaline medium and acid medium. Phosphorus compound also exhibit disproportionation reaction, that is simultaneous oxidation and reduction reactions. Let me give one example. I am going to write this on the whiteboard. Just look at the whiteboard. Intermediate oxidation state, this is +3. Oxidation state +5. Oxidation state -3. Already mentioned that in phosphorus in intermediate oxidation state disproportionate into +5 and -3. Okay, in acid medium as well as in alkaline medium. Okay, but in case of arsenic, antimony and bismuth, the +3 oxidation state is highly stable towards disproportionation. No disproportionation for arsenic, antimony and bismuth with +3 oxidation state. This is all about oxidation state. Next, chemical properties. Another chemical properties, very important chemical property, the reactivity towards hydrogen. It is again displayed on a TV screen. Let's have a look. All the elements of 15th group form hydrates of the type EH3. What is E? E is the element, belongs to nitrogen family, nitrogen, phosphorus, arsenic, antimony or bismuth. So, they form hydrates of the type EH3. What about the stability of these hydrates? It is given here, stability of the hydrates decreases down the graph. Why it decreases? See, in ammonia, the first hydrate is ammonia, then phosphine, then arsine, then stibine, then bismuthine. So, if I am writing ammonia here, NH3, the bond is between N and H. If I am writing PS3, bond is between this one. So, nitrogen smaller size, hydrogen also smaller size to some extent. Effective overlapping, very good overlapping, head-on overlapping, strong bond is formed. Phosphorus larger in size, hydrogen smaller in size. The bond strength decreases, overlapping is minimum, bond strength decreases. So, as the size increases, the tendency to undergo head-on overlapping decreases because hydrogen is smaller in size. So, as overlapping is minimum, bond strength decreases, the stability of these hydrates decreases, which also affect the reducing character. Next point, it is also given here, reducing character of the hydrates increases down the group. Why? Now, hydrogen can easily produce. What are reducing agent? Which can produce hydrogen for reduction. So, here the reducing character of the hydrates increases down the group because bond strength decreases down the group. Why bond strength decreases? Because the difference in size is more. So, overlapping is minimum, bonds are weaker. So, the reducing character of the hydrates increases down the group and the stability decreases down the group. Okay. The coming to the bond angle of hydrates also decreases down the group given. I will discuss that. Basic character also decreases down the group. And see the boiling point order, very important. See the boiling point order. The question may be asked to that arrange the hydrates of 15th group elements in decreasing order boiling point displayed on your TV screen. See, it is bismuthine greater than stibine greater than ammonia greater than arsine greater than phosphine. Okay, so this is about the one of the important chemical property of 15th group elements, that is reactivity towards hydrogen to form the hydrates of the type EH3. In the last class, we have discussed about reactivity towards hydrogen of 15th group elements. What I found, 15th group elements form the hydrates of the type EH3, where E is the elements of 15th group elements. The stability of these hydrates decreases down the group because bond strength decreases down the group due to large size difference. The reducing character of these hydrates increases down the group. Once again, bond strength decreases, so hydrogens can be easily released. The bond angle of hydrates also decreases down the group. Why bond angle decreases? For example, if we compare the bond angle between ammonia and phosphine, the ammonia bond angle 107 degree, whereas this phosphine it is around 93. Why this is so? Why bond angle decrease in bond angle? Because in ammonia, nitrogen is surrounded by 3 hydrogen, and nitrogen is more electronegative than phosphorus. So as nitrogen is more electronegative, the bonding electron pair, I mean the electron pair between N and H, this bonding electron pair is closer to the nitrogen. So electron pairs are closer to the central atom in ammonia. That is why the repulsion between bonding electron pair is more, bond angle is more. Whereas in phosphine, in PS3, phosphorus electronegativity is 2.5, hydrogen is 2.1, difference is small. So electron pair is not closer to the central atom. The repulsion between bonding electron pair is not maximum. That is why bond angle is less. So bond angle is lesser in case of phosphine. So bond angle decreases down the group. Once again, let me tell you. In ammonia, nitrogen is more electronegative. Let me show that on the whiteboard. So here the electronegativity of nitrogen is higher, so electron pairs are closer to the nitrogen atom. So repulsion between bonding electron pair is more, or repulsion is more, the bond angle is more. But in phosphine, the electron pair is not closer to the phosphorus, so repulsion is less, bond angle is less, so bond angle decreases down the group because electronegativity of the central atom decreases down the group. Next, basic character. The basic character also decreases down the group. Why? Because nitrogen being smaller in size, the electron pair is available. What do you mean by basic character here? What type of base we are discussing? We are discussing the Lewis basic character as well as the Bronsted basic character. What do you mean by Bronsted base? Proton acceptor. What do you mean by Lewis base? Electron pair donor. Bronsted base, proton acceptor. Lewis base, electron pair donor. So if the electron pair on hydrogen atom is easily available, then it is more basic. Yes, on hydrogen atom the electron pair, I mean the lone pair, is easily available. Hence it is more basic than the phosphine, whereas phosphorus being larger in size, electron pair is not easily available. Okay, so basic character also decreases down the group. Coming to boiling point, see, boiling point, once again important point. Which is the highest boiling point? Now bismuthine. Why not ammonia? Ammonia can show the hydrogen bonding. Hydrogen bonding is possible in ammonia. Okay, you know the hydrogen atoms which are usually on nitrogen, oxygen and fluorine take part in hydrogen bonding. Ammonia, in ammonia hydrogen bonding is possible, but ammonia has lower boiling point. You see displayed on a TV screen is bismuthine, which is the highest boiling point here. Why this is so? Why bismuthine is the highest boiling point? Because of high molecular mass, the force of attraction is maximum, so bismuthine has the higher boiling point, which overpower that hydrogen bond. So bismuthine, then stibine, then ammonia, then arsine, then phosphine. Phosphine has the lowest boiling point, bismuthine has the highest boiling point. This is reactivity towards hydrogen. Then reactivity towards oxygen. All these elements forms two types of oxides, E2O3 and E2O5. For example, nitrogen trioxide N2O3 and nitrogen pentoxide N2O5. The acidic character of these oxides decreases down the groove. It is obvious because metallic character increases. We know that non-metal oxides are more acidic. So that is why that acidic character decreases down the groove. Then if you compare the acidic character between E2O3 and E2O5, for example, N2O3 and N2O5, if you are comparing the acidic character, N2O3 and N2O5, let's compare the acidic character between these two compounds. Which is more acidic? In oxides or in oxoacids, greater the oxidation state of the central atom, stronger the acid. Greater the oxidation state of central atom, stronger the acid. So which has higher oxidation state? Nitrogen plus 5 here. Here nitrogen plus 3. So which is more acidic? N2O5. Okay. The oxides of the type E2O3 of nitrogen and phosphorus are purely acidic. Arsenic, antimony, amphoteric oxides, and bismuth oxide is purely basic. Okay. So these are the oxides of the 15th group elements. Okay. Next, reactivity towards halogen. See, all these points are displayed on your TV screen. These elements react to form two series of halides, EX3 and EX5. E is the element of 15th group elements. So EX3 and EX5, tendency to show EX5 or tendency to form EX5, I mean pentahalide, decreases down the group. Once again due to inert pair effect. As you know, bismuth exhibit inert pair effect. The cause of inert pair effect is in bismuth the 6s electron pair, 6s to 6p3. This is the outer electronic configuration of bismuth. That 6s electron pair is reluctant to take part in bonding. So the tendency to show plus, the pentahalides decreases down the groove. Bismuth does not want to form pentahalide. And what about nitrogen then? Nitrogen too. It does not have the tendency to pentahalide. It can't form pentahalides. No chance of pentahalide of nitrogen. Why not? The maximum covalence of nitrogen is 4. Why? If you look at the electronic configuration of nitrogen, it is 2s2 2p3. There are 3 half-filled orbital. As per the definition of covalency, 3 covalent can be formed by nitrogen. And there is an electron pair over nitrogen, that is lone pair, 2s2 2p3. 2s, that electron pair, it can donate. So all total it can form 4 covalent bond. The nitrogen maximum covalence of nitrogen is 4. But about the other elements, they can extend their covalence up to 6. Why? Because nitrogen does not have vacant orbitals, no d orbital, no vacant d orbital. Nitrogen belongs to second period. All the second period elements do not have vacant orbitals. Vacant d orbitals. Phosphorus, etc., they have got vacant d orbital. They can extend their covalency up to 6. Okay, that is why the nitrogen does not form pentahalide, though it exhibits plus 5 oxidation state. Nitrogen can't form pentahalide due to absence of d orbital. Nitrogen can't form pentahalide due to absence of d orbital. But rest of the element, they can extend their covalence up to 6. Okay, student got the point. This is important. The question may be asked you that why nitrogen cannot form pentahalide where phosphorus does form pentahalide. Nitrogen cannot form pentahalide due to absence of vacant d orbital. Phosphorus has got vacant d orbital, so it can form pentahalide. This is one of the important questions. That question may be asked you. Coming to other properties, all the trihalides of these elements except those of nitrogen are stable. Nitrogen trihalide unstable except NF3. Nitrogen trifluoride is stable. NCl3, NBr3, NI3 unstable. They explode. Okay, so it is given here. Nitrogen does not form pentahalide due to non-availability of d orbital in its valence shell. It is mentioned also displayed on your TV screen. I have already told you, I have already discussed about this. Pentahalides are more covalent than trihalides. Yes, with increase in oxidation state, tendency to show covalent character increases. Why this is so? It is due to Fajan's rule. According to Fajan, with increase in oxidation state of central atom, that covalent character increases, polarization power increases, covalent character increases. So that is why if you compare the covalent character between PCl5 and PCl3, PCl5 and PCl3, which is more covalent? PCl5. Why? Oxidation state of phosphorus plus 5. That is why. Trihalides except BiF3 are predominantly covalent. Even all the trihalides are covalent, but BiF3 is ionic. Okay, so this is one of the important property also. These are the chemical properties. Next, compounds of nitrogen. Nitrogen is an important and essential constituent of proteins and amino acids. Nitrates and other nitrogen compounds are extensively used in fertilizers and explosives. First, we will discuss about the preparation of nitrogen. See, how does nitrogen gas prepared in laboratory? Very simple, we can prepare nitrogen gas in laboratory. How come? Now, you take ammonium chloride and sodium nitrate which are available in laboratory, prepare a mixture and heat it. You will have the nitrogen gas displayed on a TV screen. See the reactions. Important reaction. Question may be asked you, what the question? What the question you can expect here? What happens when the mixture of ammonium chloride and sodium nitrate is strongly heated? Answer: nitrogen, NaCl and water. Nitrogen gas is liberated. Okay. Or this question may be asked you like this also. What happens when the ammonium nitrate is strongly heated? Nitrogen gas displayed on a TV screen. Is that clear? So this is the first method of preparation. Another question can be expected here. See, second, how can you prepare nitrogen gas? See, displayed once again displayed on a TV screen. There is the question may be asked you like this. Okay, what type of question you can say? An orange colored solid A, orange colored solid A, on heating, strongly heating, gives a green residue and an unreactive gas. Orange colored solid, what could it be? If I think about the orange colored solid, it could be potassium dichromate. Okay, potassium dichromate, we know that is orange colored solid. So it could be the dichromate salt. Here it is unreactive gas. On heating gives an unreactive gas. We know that nitrogen is unreactive. Why it is unreactive? Because N triple bond is there. Bond dissociation energy is too high. Bond dissociation energy too high. So very difficult to break up the nitrogen molecule or dissociate nitrogen into nitrogen atoms. So ammonium dichromate, it is displayed on TV screen. Once again, let me write on the whiteboard. Say ammonium dichromate on strong heating, nitrogen gas on reactive, Cr2O3 green residue, green, and this is orange. See, orange colored solid A on strong heating liberate unreactive gas nitrogen and a green residue Cr2O3 is formed. This is also important method of preparation. And if you want pure nitrogen gas, these are the methods which are displayed on a TV screen. That is barium azide and sodium azide on strong heating liberate nitrogen gas, pure nitrogen. Nitrogen, we know that nitrogen has the in air nitrogen has 78% by volume. That means in 100 ml of air there is 78 ml of nitrogen. So nitrogen can also be manufactured, nitrogen can also be separated by fractional distillation of air. Okay, fractional distillation, why? Because nitrogen and oxygen both are present in air. Nitrogen boiling point is nitrogen has lower boiling point than oxygen, so nitrogen can be separated from oxygen by fractional distillation of air. Coming to properties of nitrogen gas: colorless, odorless gas, very less soluble in water, reaction with oxygen, bonds with oxygen at high temperature around 2000 Kelvin. The reaction is possible. Once again, why high temperature required? During lightning, this gas NO gas is also produced. Why? Because the high temperature required can be made from the lightning. Nitrogen, it has high bond dissociation energy, so high temperature is required. Nitrogen combines with the oxygen to give NO, I mean nitric oxide at high temperature. Uses displayed on a TV screen for providing inert atmosphere during many industrial process, also for manufacture of ammonia by Haber's process, etc. Okay. It is also used as a refrigerant to preserve biological materials. So, this is about the nitrogen gas. So, the important questions are there in nitrogen gas. How can you prepare nitrogen gas in laboratory, or what happens when the mixture of ammonium chloride and sodium nitrate is strongly heated, or what happens when ammonium dichloride is strongly heated, or identify the gas which is liberated when an orange solid on strong heating gives an unreactive gas and a green colored residue. These are the questions you can expect from nitrogen. So, we have already discussed about the preparation, properties and uses of nitrogen gas. The next compound of nitrogen we are going to discuss is ammonia. I have already told you that ammonia is a poisonous gas, but let us first see how ammonia can be prepared. Ammonia is usually prepared by action of alkali, on ammonium salts. Why this is so? Students, it is very easy to remember. Any alkali you take and just heat it with ammonium salts, you will find ammonia gas. Even if we know that there is a soda lime test for the that is test of ammonium basic radical. You know, soda lime, mixture of caustic soda and quicklime, NaOH and calcium oxide. So, sodium hydroxide and calcium oxide, that mixture is soda lime. You take ammonium salts in a palm tub, then add soda lime to it and drop it, you will find ammonia gas if you want to inhale the gas. So, ammonium salts with alkali liberate ammonia gas. Why this is so? Because ammonium cation is acidic. That means we can remove H plus ion, it can donate H plus ion. So, just remove the H plus ion. Which can remove the H plus ion? Which compound will remove the H plus ion from the ammonium salts? Sodium hydroxide, OH minus is there. So, ammonium salts NH4 plus with alkali OH minus ion, remove H plus ion, this is acidic. It removes H plus ion, so ammonia is there and water. Okay. So, this is one of the very important method of preparation of ammonia gas, that action of alkali on ammonium salts liberate ammonia gas. Industrial method of preparation, you know, the Haber's process, ammonia gas on a large scale. That means if you want ammonia gas in a large volume, it is prepared by Haber's process. What is that? It is displayed on a TV screen. N2 plus 3S2 at high temperature and at high pressure, ammonia gas is liberated. Nitrogen reacts with hydrogen gas at high temperature and high pressure, liberate ammonia gas. So, this is Haber's process. The reaction is reversible, reaction is exothermic, I mean heat is evolved. Nitrogen reacts with hydrogen to liberate ammonia gas. So, what are the principle we have to follow? What are the conditions we have to follow so that yield of ammonia can be increased? We can apply the principle called Le-Chatelier principle. What are the conditions to be followed to increase the yield of ammonia? High pressure. According to Le-Chatelier, any increase in pressure or equilibrium always shifts the equilibrium in the direction having lesser moles. So, since the formation of ammonia is accompanied with decrease in number of moles, this is the reaction. Formation of ammonia. Okay. This is ammonia is formed. It is accompanied with decrease in number of moles. 2 moles are here. Here 4 moles. So, any increase in pressure or equilibrium always shifts the equilibrium in the direction having lesser moles. This is in accordance with Le-Chatelier principle, students, you know this. Then the number 1 condition, high pressure. The reaction is exothermic. Any increase in temperature always shifts the equilibrium in the endothermic directions. any increase in temperature always shifts the equilibrium in endothermic directions. So here reaction is exothermic, backward reaction is endothermic. Okay, so if you will increase the temperature, equilibrium shifts in backward directions. So yield of ammonia is not increased. That is why low temperature decreases temperature, so that equilibrium shifts in forward directions and the required heat is there. Okay. Then excess of reagent you can use, and then use of catalyst. What the catalyst here? It is given catalyst such as iron oxide with a small amount of K2 and alumina, potassium oxide, alumina and Fe2O3 or iron promoted by molybdenum. So these are the conditions to be followed in order to increase the yield of ammonia gas. Then physical properties, ammonia is a colorless gas with a pungent odor. I have already told you this is a poisonous gas. Highly soluble in water. Ammonia is highly soluble. Why? Due to hydrogen bonding with water. Ammonia can form hydrogen bond with water, so it is highly soluble. Chemical properties, it is basic, so its aqueous solution gives OH minus ion. It also forms salts, insoluble precipitates with certain compounds such as ferric chloride with ammonium hydroxide gives a brown precipitate, zinc sulfide with ammonium hydroxide gives the white precipitate. So it gives precipitate, insoluble precipitate with certain compounds. And ammonia, as you know, shape of ammonia, what is the shape of ammonia? Pyramidal. Why it is pyramidal? You know, ammonia, the nitrogen is sp3 hybridized, nitrogen is sp3 hybridized, it should be tetrahedral. Why it is pyramidal? Due to presence of the lone pair of electron on nitrogen atom. So due to presence of the lone pair of electron, it acts as a Lewis base. It's so complex, it has the complex forming ability. It can form complex, it acts as a ligand to form complex. The examples are displayed on your TV screen. Let's have a look. It forms a complex with cupric cation to form tetraamine copper 2 ion. It also forms complex with AgCl. You know, AgCl is a white precipitate but dissolves in ammonia. Why? Due to formation of this complex diamine silver 1 chloride. The IPAC name diamine silver 1 chloride. So it has complex forming ability. That means it acts as a Lewis base or acts as a ligand due to presence of the lone pair of electron on nitrogen atom. Then oxides of nitrogen. Oxides of nitrogen, nitrogen forms so many oxides. It is displayed on a TV screen, you see. It forms, the first oxide is N2O, which is linear in shape, N2O. The resonating structures are also displayed. N2O is linear, it is called laughing gas. Then NO, odd electron molecule, paramagnetic. It can also be proved from the by applying molecular orbital theory. NO is paramagnetic. Okay, why? Due to presence of the odd electron. Then N2O3, see the N2O3 molecule, nitrogen sesqui oxide or nitrogen trioxide, you see. See the bond angle between ONO. Bond angle is very close to that 135, 134 usually. Whereas the bond angle HNN, the bond angle is smaller. Why? The bond angle is greater in that case because there is multiple bond N double bond O. Okay. So as multiple bond, single bond repulsion is greater, bond angle increases. That is the reason you see in all the nitrogen oxides, the bond angle ONO bond angle is very close to 134 degree. Okay. So why bond angle is higher? It is due to more repulsion between multiple bond and single bond. As you know, multiple bond, single bond repulsion is greater compared to single bond repulsion. So these are the oxides here, N2O3, then NO2. NO2 is also paramagnetic. NO2 because it has got an odd electron. NO2 is brown colored but it is paramagnetic. And N2O4, this is diamagnetic because NO2 dimerages to N2O4, diamagnetic. Then N2O5, nitrogen pentoxide, which exists as a solid, and in solid form it is ionic, NO2 plus, NO3 minus. I repeat, N2O5 is a solid. In solid state it exists as NO2 plus and NO3 minus. Coming to nitric acid, which is also called aqua fortis. Nitric acid, aqua fortis, strong water. The structure of nitric acid displayed on a TV screen. How to prepare nitric acid in the laboratory? Once again, displayed on a TV screen. See, how does nitric acid prepared in laboratory? It is by action of H2SO4 and sodium nitrate. We can prepare nitric acid in laboratory. Then the second method, that is industrial method, is Ostwald's process. So how can you prepare nitric acid by Ostwald's process? Here ammonia is oxidized by oxygen of the air in presence of platinum gauge to form nitric oxide. Ammonia first of all oxidized by oxygen, important reaction. What happens when ammonia and air is heated in presence of platinum? It gives nitric oxide and water vapor. So nitric oxide is there. Nitric oxide reacts with oxygen to form NO2, nitrogen dioxide gas. This nitrogen dioxide gas with water gives HNO3 and NO. The NO thus formed can be recycled. This is the Ostwald process. Remember what the important question here, that what happens when ammonia is oxidized by air in presence of platinum. Properties, physical properties displayed, colorless liquid, freezing point this 231.4 Kelvin. In the gaseous state, HNO3 exists as a planar molecule, etc. These are given on the TV screen. You can have a look here. Then chemical properties, it can oxidizes most of the nonmetals and their compounds, again displayed on a TV screen. See, it oxidizes that boron to orthoboric acid, phosphorus to phosphoric acid, arsenic to arsenous acid, sulfur to sulfuric acid, that is ec acids are formed, and hydrogen sulfide to sulfur, etc. It also has different actions on metals. Metals with electropositive metal it shows acidic oxidants, and with less electropositive metals such as copper, it shows oxidizing oxidants followed by acidic oxidants. With electropositive metal, I mean the metals which are placed above hydrogen in electrochemical series. With these metals, the nitric acid first shows acidic oxidants followed by oxidizing oxidants. But with metals which are placed below hydrogen in electrochemical series such as copper, with it first shows oxidizing oxidants followed by acidic oxidants, because nitric acid functions both as oxidizing agent as well as acid. Nitric acid, why it acts as an oxidizing agent? Because nitrogen has oxidation number +5. It is a strong oxidizing agent. Nitrogen oxidation number +5. It is the highest oxidation number. It can't be oxidized further. It can't be oxidized further. I mean +5. It can't oxidize. It can show the oxidation state, higher oxidation state than +5. It can only shows decrease in oxidation number +5 to -3. So it shows oxidizing oxidant only. What is the oxidizing agent? The substance which can reduce itself. HNO3 can only reduce because nitrogen is in +5 oxidation state. Okay, students. So these are the 15th group elements and their compounds. We have discussed this in detail. We also covered that ammonia, nitrogen, nitric acids, and the physical properties. The questions we have also discussed what type of questions expected. I have already discussed. That's all for nitrogen family, nitrogens or 15th group elements. Thank you.